Feed an unconstrained language model a mix of hard financial data and generic market noise, and it will process both with the same semantic weight. The system attempts to smooth over gaps and interpolate missing variables. In casual conversation, we call this creativity. When parsing complex public company data, it generates plausible but misleading hallucinations. Financial analysis requires an absolute grounding in filing-backed fundamentals, specifically SEC EDGAR evidence, to ensure every claim can be traced to a primary source. Delta Signal ATLAS-7 is engineered as an architectural countermeasure to this problem. It replaces the entropy of unconstrained text generation with a deterministic, programmable intelligence engine. The central rule of the platform is strict. AI output in financial systems must act as an immutable evidence package, never a generated opinion. To maintain this constraint, we have to map the exact flow of data. The pipeline moves from the ingestion of raw SEC XBRL evidence through the deterministic ATLAS-7 engine and finally into agent-ready contracts. By constraining an autonomous agent to this specific pipeline, the architecture sets a boundary where the analysis can only proceed if the underlying evidence is present. The evidence layer starts at the bedrock of public financial reporting. Every cycle begins with a nightly background task targeting the EDGAR database. The pipeline does not estimate or forecast. It physically waits for the SEC's raw CompanyFacts dataset to be published, mirrors it, and only then initiates downstream processing. That feed runs through a module called Process Changes, extracting a predefined universe of 215 crypto-exposed public companies. Here, identities are standardized and daily deltas are calculated. The data is then sorted into specific pillars: risk distribution, fundamentals, peer ranking, and covenant stress. Generic token-level sentiment is excluded. The framework relies exclusively on filing-backed fundamentals for its issuer intelligence. While ATLAS-7 rows are highly structured, passing them directly to an autonomous agent is still insufficient. Without strict contextual boundaries, an LLM might still misinterpret the scope of these numbers. Isolating the analytical baseline to normalized SEC identity and verified daily changes ensures the intelligence engine is constructed entirely on empirical evidence. To control how agents read the data, the system adds a secondary layer: SPECTRA field map contracts. SPECTRA's mechanical function is to read the historical ATLAS data rows and generate rigid, machine-readable contracts that dictate the rules for every field. This contract permanently attaches metadata to every data point. Queries return the exact source date, provenance lineage, and caveats. Crucially, this includes the soft miss state, flagging when a metric is unavailable for that issuer, preventing the agent from making assumptions. The system enforces a strict boundary here. An agent can explain SPECTRA evidence, but it is mathematically prohibited from attempting to fill blank rows. Missing data must be treated as missing data. It is not an invitation for the agent to interpolate or guess. By deploying explicit, machine-readable declarations of absent data, the pipeline creates a safeguard that prevents an agent from inventing facts to satisfy a user prompt. With the internal data structure secured, the next step is connecting autonomous agents to the pipeline through a standardized interface. Delta Signal utilizes the Model Context Protocol, or MCP. This allows agents to query the server and map what the system can do without relying on hard-coded instructions.
Traditional API integration often relies on brittle endpoint guessing. To bypass this, the pipeline implements Arazzo plans. Arazzo serves as the translation layer. It takes raw human intent and maps it to a strict, bounded sequence of actions. As planning transitions to execution, the system routes these requests through server-side composite presets. This groups necessary API calls together, ensuring the agent follows a predictable execution path. If a user requests a morning brief, the agent reads the Arazzo scenario, identifies the correct composite route, and executes a predefined market readiness scan. Separating discovery, planning, and execution into machine-readable protocols gives the agent exact parameters for its task, achieving autonomous operation through predictable, machine-readable steps. Autonomy in data extraction eventually hits a practical bottleneck: resource consumption. Once free public discovery limits are reached, granular data execution requires settlement. Instead of simply blocking the agent, the server issues an HTTP 402 payment challenge. This response provides the agent with the precise requirements for resolution. This initiates the public MCP X402 handshake. The server returns metadata containing the specific network, the base USDC asset requirement, and the route pricing. The agent settles the transaction on the base chain, retrying the call with a cryptographic payment proof. The server verifies the proof, removes the barrier, and unlocks the structured evidence payload for clients. This execution framework operates independently of manual account provisioning or traditional credit card inputs. The machine handles the entire procurement cycle. Enabling scalable, machine-driven financial data markets that operate through automated protocols is an essential step for scaling agentic intelligence. The unlocked evidence payload arrives back at the client, where it meets the final rendering constraint. The agent is permitted to compile the structured JSON into readable Markdown, but its role is limited to that of a formatter. It does not act as an independent reasoning engine. To ensure report integrity, specific metadata must survive. The final document always displays the publication audit block, source dates, evidence hashes, and a non-advice boundary. If data is missing, the display requirements force the agent to surface that caveat. The interface is designed to make DATs and evidence highly visible to the end user. Restricting the natural language layer to evidence formatting ensures that the structural fidelity established during the initial EDGAR ingestion survives the final formatting process. The Delta Signal pipeline is a closed, secure system. Data flows from a verified source, constrained at every step until it reaches the final output. It begins with the precise ingestion of SEC XBRL filings, filters through the deterministic logic of the ATLAS-7 engine, and is bound by the provenance of the SPECTRA field maps. The delivery of that data is orchestrated by MCP, planned by Arazzo, and autonomously settled via the X402 protocol. This structural rigor stands in direct opposition to unconstrained chat interfaces, where statistical probability often leads to errors in complex financial analysis. The rule for engineering financial AI is clear. High signum outputs require verifiable, machine-readable provenance. Bounded workflows and evidence-preserving pipelines are the mandatory architectural foundation required to deploy autonomous agents safely in live financial markets.